Using Kubernetes for container orchestration involves managing and automating the deployment, scaling, and operation of application containers. Here's a guide on how to effectively utilize Kubernetes. 1. Understanding Kubernetes. Kubernetes is an open-source container orchestration platform that automates the deployment, scaling, and management of containerized applications. It provides a robust framework for managing clusters of containers across multiple hosts. 2. Setting up Kubernetes. Start by installing Kubernetes on your local machine using tools like Minikube for testing and development, or set up a production-grade cluster on cloud platforms like Google Kubernetes Engine, GKE, Amazon Elastic Kubernetes Service, EKS, or Azure Kubernetes Service, AKS. 3. Defining Kubernetes objects. Use Kubernetes objects such as pods, services, deployments, and config maps to define the desired state of your application. Pods are the smallest deployable units that can contain one or more containers. 4. Deploying applications. Create Kubernetes deployment objects to define how applications should be deployed and managed. Deployments ensure that a specified number of pod replicas are running at any given time, handling updates and rollbacks seamlessly. 5. Scaling applications. Kubernetes enables horizontal scaling by adjusting the number of pod replicas based on CPU or custom metrics using horizontal pod autoscalers, HPA. This ensures applications can handle varying levels of traffic efficiently. 6. Managing configuration and secrets. Use config maps to decouple configuration settings from container images, making it easier to manage and update configurations. Kubernetes secrets store sensitive data such as API keys and passwords securely. 7. Service discovery and load balancing. Kubernetes services provide a consistent way to access and load balance applications running within pods. Services abstract the network and ensure reliable communication between microservices. 8. Monitoring and logging. Integrate Kubernetes with monitoring tools like Prometheus and Grafana to monitor cluster health, resource usage, and application performance. Use logging tools like Elasticsearch and Fluentd for centralized log management. 9. Continuous integration and deployment, CI/CD. Implement CI/CD pipelines to automate the build, test, and deployment of containerized applications on Kubernetes. Tools like Jenkins, GitLab CI/CD, and Tekton help streamline the development workflow. 10. Ensuring high availability and resilience. Configure Kubernetes for high availability by running multiple replicas of critical components like the control plane and application pods across different nodes. Use features like pod anti-affinity and node affinity for workload placement strategies. By mastering these aspects of Kubernetes, developers and DevOps teams can leverage container orchestration effectively to deploy, manage, and scale containerized applications with enhanced efficiency, reliability, and scalability in both development and production environments.